So for this series that I have, in fact, if you look at some partial sums, you might get an idea. But this one, you could probably look at and just look at it in your head and say, well, if I keep adding 1/2, this is surely going to diverge. Yes?
Is there any arithmetic sequence that converges?
I have to think about that. Yes.
Is this just how it converges because it's arithmetic?
The series diverges. And because if I look at what is S sub 1, that's 1. What is S sub 2? That's 1 plus 1/2. That's 3/2. What is S sub 3? That's 1 plus 1/2 plus 1/2. That is 4/2, which is 2. S sub 4 would be 5/2. S sub 5 would be 6/2. This sequence of partial sums is not going to approach one particular number. And actually, for a problem like this, I would sort of expect you could look at it and say diverges without giving me much explanation. I would be fine with that. So why did I show this problem? Because of this next one. Here's my next example. I want to know if this next series diverges or converges. And it's the sum as n goes from 1 to infinity of 1 over n. Does this series converge or diverge? I've had students before say something like, I hate to even say this because it's not true. They'll say something like, since this 1 over n is going to 0, they'll say it converges. But that's not true. That's not true.
That's not.
No. That's people trying to flip the test for divergence and it doesn't work. Okay, look. So I got to figure out if this converges or diverges. Let's look at some partial sums. Look at some partial sums. So S sub 1, what's 1 over 1? 1. S sub 2, by the way, partial sums, I hope you were caught on to this. If I'm doing S sub 2, I'm starting at 1 for n, and I'm going to 2, and then I'll stop. So this would be 1 over 1 plus 1 over 2, and that's 3/2. S sub 3 would be 1 plus 1/2 plus 1/3, whatever that is. S sub 4 would be 1 plus 1/2 plus 1/3 plus 1/4. And right here, I want to step back a little bit. And I'm going to ask you a question that might sound a little silly. Is 1/3 bigger or smaller than 1/4? Bigger. So I'm looking at S sub 4. S sub 4 is greater than 1 plus 1/2 plus 1/4 plus 1/4. And all I did is I said, well, here I have 1/3, here I have 1/4, and look, I changed it to greater than. It's not an equals. So that statement's true. What's 1/4 plus 1/4? That's 1/2. So look what I got. S sub 4 is greater than 2. S sub 5. Actually, the next one I'm interested in is S sub 8. So I said, okay, I'll kind of give lip service to S sub 5, S sub 6, S sub 7, but I want to look at S sub 8. S sub 8 is 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8. And we've already talked about 1/3. 1/3 is greater than 1/4. So I'm going to put here S sub 8 is greater than 1 plus 1/2. 1/3 is greater than 1/4. I'm going to keep 1/4 as 1/4. 1/5. Is 1/5 greater than 1/8? Yes. Is 1/6 greater than 1/8? Yes. Is 1/7 greater than 1/8? Yes. So I'm going to say, well, you know what? S sub 8 is greater than, if I change all of these to 1/8, up to that 1/8. Okay, so 1/4 plus 1/4, that is 1/2. What about 1/8 plus 1/8 plus 1/8 plus 1/8? That's 1/2. So S sub 8 is greater than 1 plus 1/2 plus 1/4 plus 1/2 here. Okay. 1 plus 1/2 plus 1/2 plus 1/2. S sub 8 is bigger than that number. When I keep going with partial sums, the next one I would look at is S sub 16. What there, after if I did S sub 9, I'd have 1/9, but my 1/9 is greater than 1/16. 1/10 is greater than 1/16. What is 1/16 added to itself 8 times? It's 1/2. So I'm getting these partial sums that are bigger than this guy, which we've already said diverges. So if I have, or I'm getting partial sums that are bigger than the partial sums of this series, and we've already said this series diverges. So if this one has bigger partial sums than one that we know diverges, then what about this one? It is going to diverge. This series diverges. It's kind of the classic example of one that diverges, but yet the sequence part does go to 0. So that's worth writing out. Notice on this series, n going from 1 to infinity of 1 over n, we get a sub n, the sequence is 1 over n, and as n approaches infinity, a sub n converges to 0, but the series diverges. This is the nice example that you cannot flip those two parts for the test for divergence and get convergence. You cannot say that if a sub n is going to 0, the series converges. That doesn't work. So what happens? If a sub n is going to 0, you don't have enough information about the series. you got to try something else. Now, this series is given a special name, and so you're going to need to know this name. This series is called the Harmonic Series. So whenever we say Harmonic Series, we're talking about this guy right here. This is called the Harmonic Series. And you put this in your toolbox. The Harmonic Series diverges.